Hi, my name is Deidre, and this is my senior project documentary, and we're going to be talking about climate change. For our current generation, climate change is quite possibly the most pressing global issue that is often ignored in the media, and that the answer seems just unclear on how we're going to fix our situation. The surplus output of carbon, a gas which traps heat in the Earth's atmosphere, causes a rise in global temperatures, altering the habitats of many animals that rely on a consistency in cooler temperatures in order to live healthy lives. Though the outlook at the moment seems extremely negative considering the amounts of damage that have been done already, it's not possible to not reverse it. We do still have some time according to experts. Many climate-saving ideas, including the reduction of carbon-producing fuels, have been proposed in recent years, yet very few plans have been implemented and carried out worldwide. In these times of lack of state participation, scientists have turned to new technologically challenging ideas, such as using resources in space instead of using the ones we have on Earth, or setting up colonies on Mars. Mars has become the focal point of research in recent years due to its location in the Goldilocks zone, which is the zone of distance from the Sun for which liquid water can exist. Its relatively close distance to Earth of 58.8 million miles, and its life-supporting elements in its atmosphere. Another reason for the extensive research on the planet is, if resorted to as a last-ditch effort, it would host several colonies of people in order to evade the likely catastrophic events that greenhouse gas emissions would have on the Earth's atmosphere. The prominent question is, however, is it possible for this to even happen? Do us as humans have the means and the technologies to send human life on a makeshift Earth? To answer this question and more, I interviewed Dr. Philip Metzger, a planetary physicist who worked for NASA for over 30 years developing Martian landing technologies and other space mission technologies. Although I was unable to record our interview due to technological issues, I was able to hear his professional voice on the possibility of colonizing Mars as a climate emergency plan, as well as other environmental alternatives involving the use of space materials that he has done research on in recent years. According to Dr. Metzger, one of the main issues with NASA colonizing Mars is that they don't have enough government money to do an actual Mars mission with actual people, due to habitats, rockets, and etc. being just too much to build all at once. Sustainable exploration, however, has been the more substantial topic in terms of positive environmental impact using space. Sustainable exploration, as said by Dr. Metzger, uses other technologies to harvest space materials to use for construction of other spatial infrastructure for which commercial space can accomplish, and makes NASA one of its customers. Despite the seemingly breakthrough that sustainable exploration could have for Mars missions, Dr. Metzger brings up a valid point that our bodies are just not adapted to Mars. We can't breathe the air, there's no protection from radiation, and there's no magnetic field. During our interview, Dr. Metzger presented me with the three most challenging aspects of trying to colonize Mars. 1. Can people survive long-term with the amount of radiation and still be healthy? 2. Will our bodies be okay in the 3/8 of gravity that, in compared to Earth, is much smaller? And 3. With no atmosphere, people would have to stay inside all the time, so how could we enable people to go outside without specialized safe suits so that they are okay mentally? Although the first two questions are very difficult to answer, there is still some ambiguity with the third one. Although the use of cyanobacteria has been the main research focus in terms of methods to thicken the extremely thin Martian atmosphere, the speed at which the bacteria would thicken the atmosphere is too slow for any notable progress within the next few years. In our interview, Dr. Messer also suggested that the heating of the atmosphere would help thicken it much faster than cyanobacteria would, and using brute force methods such as sending water-rich comets crashing into the planet, thus releasing water vapor, would help increase the temperature significantly at a faster rate. Yet, this would require a period of cooling time which is unknown. Even if we had a large enough self-sacrificing industry and it could work, the time constraint is the key issue here. Due to the many implications that are present when attempting to establish a settlement on Mars, the idea is almost completely out of the question if we want to have a settlement that could be used to evade climactic ruin in the near future. So what can we do to avoid climactic damage due to carbon emissions? The most effective answer is often more simple. Energy resources that produce carbon dioxide as a byproduct, such as coal, oil, and natural gas, are not only the most common types of energies used in the world, but they are also the most environmentally hazardous. So why do we use them? The short answer is they're just the most readily available to us. The slightly longer answer being that because they're so readily available, there's a lack of motivation to implement/develop new technologies that produce clean energy. There is some hope, however, as some state-based power companies, such as Georgia Power, are working to develop and make available clean energy alternatives to homeowners across the state. One newly developing clean energy plant for Georgia Power, Plant Vocal, is designed to bring nuclear energy to hundreds of thousands to almost 1 million homes. But what benefits to the environment does the plant actually provide? To answer this question and to get an outside look of the already existing and the new cooling towers being constructed, I toured Plant Vogel with Michael McCracken so that I could learn more about the benefits of nuclear energy and the reasons for the negative stigma behind it. As mentioned before, Plant Vocal is a nuclear energy plant, and the way that nuclear energy is created, although dangerous if the right precautionary measures are not put into place, which will be discussed later, has a significantly high energy production rate with relatively little waste. According to Mr. McCracken, a single pellet of uranium has the same energy potential as 150 gallons of oil, 1 ton of coal, and almost 20,000 cubic feet of natural gas. But how exactly is this energy harvested from this small pellet? Within the containment vessels, which are the large dome buildings as you can see, fuel rods in the reactor cores contain the uranium oxide pellets, as we just saw, and when the atoms are split through nuclear fission, energy is released in the form of heat, which is used to heat water that surrounds the hot fuel rods, creating steam. The steam then turns turbine blades, which causes them to spin a magnet inside of a coil of a wire in a generator, creating an electrical current. The smog that you see coming out of the cooling towers is just the remaining water vapor, which, although it is a greenhouse gas that traps heat in the atmosphere, it is significantly less damaging than its carbon dioxide counterpart. 96% of the water used to cool the reactor vessels and generate steam is reused. The rest is what comes out of the cooling towers and into the atmosphere. The biggest drawback to the use of nuclear energy is the uranium waste after fission is completed. Because the spent uranium leaks radiation, it must be stored completely underwater so that no radiation harms anyone. One of the ways Plant Vocal and many other nuclear plants prevent radiation leaks is through a backup water supply, which is stored in tanks above the reactors so that if there are any issues, the water can be used to prevent leaks. The biggest drawback also includes the question of what to do with the uranium waste, as it can no longer be used for the production of energy and is still extremely dangerous, especially if it gets into the wrong hands. Abandoning the uranium in the middle of the Sahara Desert has been suggested according to Mr. McCracken, yet it still avoids the problem of actual disposal. Despite this drawback, however, nuclear energy is still an extremely efficient and clean form of energy, and considering that all forms of generating electricity has its drawbacks, such as coal producing carbon monoxide and other fossil fuels doing the same, this really isn't that big of a deal. So which really is the better option? Do we continue to prepare ourselves for what seems to be the inevitable, or do we try to fix it, preventing what seems to be impossible? Based on my discussions with professionals Dr. Metzger and Mr. McCracken, and the ideas I've developed with them through my time spent talking with them, I truly believe that we can solve the climate crisis by switching to renewable energies. Yet the idea of setting up a last resort colony for the future, even if on a planet other than Mars or another spatial body, should still remain in question for hope of a better future.